Lake Jackson is one of the most remarkable natural lakes in North Florida. Located in Leon County, roughly 10 miles north of Tallahassee, the lake can spread across nearly 4,000 acres when water levels are at their highest. At its deepest point, it reaches around 15 feet. For generations, Lake Jackson has been known as an important destination for fishing, boating, and outdoor recreation throughout the Florida Panhandle. But beneath its calm surface lies something far more unusual. Geologically speaking, Lake Jackson is not an ordinary lake. It belongs to a rare category known as a prairie lake, a type of lake found in regions where surface water is directly connected to the underground Floridan aquifer. This enormous groundwater system stretches beneath much of Florida and reaches into neighboring parts of Georgia, Alabama, and South Carolina. That connection is the secret behind Lake Jackson's strange behavior. The lake sits above a landscape shaped by karst geology, where limestone has been slowly dissolved by water over thousands and even millions of years. Beneath the lake are natural openings and underground drainage pathways. Under the right combination of groundwater pressure and hydrological conditions, water from the lake can suddenly begin moving downward, disappearing through the limestone and into the aquifer below. And when that happens, Lake Jackson can practically vanish. When underground conditions change again, the process reverses, and the lake begins to return. Historical records from Leon County show that this extraordinary cycle has been occurring since at least the early 19th century. Over the decades, researchers have documented the lake draining and refilling repeatedly, often with roughly 15 to 25 years separating major events. But the drainage recorded in December 2025 brought renewed attention to a geological process that has been unfolding beneath North Florida for generations. The water does not simply disappear at random. It moves through specific geological features hidden beneath the lake. One of the most important is known as Porter Hole, located on the southwestern side of the basin. Under normal water levels, it remains completely hidden. But as the lake begins to empty, the surrounding limestone becomes exposed, revealing the geological structures responsible for the dramatic disappearance. Another feature, called lime sink, lies along the northeastern shoreline. During major drainage events, it can act as an additional pathway through which water escapes the surface basin. For years, sediment, vegetation, and organic material can gradually build up around these openings. This natural accumulation may temporarily restrict the movement of water, allowing the lake to remain full for long periods, but eventually, the balance can shift. Changes in groundwater pressure, rainfall patterns, and the weight of the water sitting above the basin can alter the conditions underground. When the natural barrier can no longer hold, the drainage system becomes active again, and then the lake begins to empty. In a remarkably short period of time, billions of gallons of fresh water can move through the limestone beneath Lake Jackson and into the vast underground aquifer system below. By December 2025, drone footage captured the astonishing result. A lake that had once appeared to be a massive body of water was transformed into a largely exposed basin, revealing features that normally remain hidden beneath the surface. For the residents of Leon County, this phenomenon is not entirely new. They have watched Lake Jackson disappear and return across multiple generations. But for anyone unfamiliar with Florida's geology, the sight can seem almost impossible. The lake is real. The disappearance is real, and the underground geological system responsible for it is real. To understand how Lake Jackson can drain so dramatically, however, you have to look beneath Florida itself. Because the Florida that people see on the surface is only part of the story. Deep below the beaches, forests, cities, and highways is a vast geological foundation built primarily from carbonate rock, especially limestone and dolostone. This geological platform began forming roughly 150 million years ago and extends far beyond the modern coastline. Over immense stretches of geological time, rising and falling sea levels repeatedly exposed and submerged the Florida platform. Marine environments covered the region, leaving behind layer upon layer of shells and skeletal remains from countless organisms. Eventually, those deposits were compressed and transformed into limestone. And limestone has a very unusual characteristic. It can dissolve. Rainwater absorbs carbon dioxide as it passes through the atmosphere and soil. This creates a mildly acidic solution capable of slowly dissolving calcium carbonate, the primary component of limestone. Over thousands and millions of years, that process reshapes the landscape from below. The result is what geologists call karst terrain. Karst landscapes are defined by underground drainage systems and unusual surface features: sinkholes, caves, disappearing streams, underground rivers, and hidden channels that can move enormous volumes of water beneath the ground. Florida is one of the world's most extensive examples of this kind of environment. Beneath the state's surface, the limestone has been gradually carved and reshaped for millions of years. Some of the resulting spaces are microscopic, while others form enormous underground cavities and passageways. This means that what looks like solid ground from above can be completely different beneath the surface. In geological terms, Florida's limestone foundation behaves less like an impenetrable slab of rock and more like a giant natural sponge, one filled with countless cracks, pores, tunnels, and hidden pathways through which water is constantly moving. And Lake Jackson sits directly within that extraordinary underground world. What appears to be a peaceful North Florida lake is actually part of a much larger hydrological system, one where the boundary between surface water and groundwater can suddenly disappear. That is why Lake Jackson can vanish, and that is why, sooner or later, it can come back. The Floridan Aquifer is the product of this dissolution. Floridan Aquifer describes the connected voids and channels in the rock. The aquifer underlies all of Florida and extends into Georgia, Alabama, and South Carolina, approximately 100,000 square miles of interconnected groundwater storage. It is one of the most productive aquifer systems in the world, supplying drinking water to millions of people and supporting agricultural irrigation across the southeastern United States. The aquifer is not a single underground lake. It is a three-dimensional network of saturated limestone, water filling the pores, fractures, and conduits throughout the rock. The water moves through the system under pressure, flowing from recharge areas where rainfall infiltrates the ground toward discharge areas where the water returns to the surface. The pressure relationships are critical. Where the aquifer pressure is high, water tends to move upward, emerging at springs like Wakula Springs, one of the largest and deepest freshwater springs in the world, located approximately 15 miles south of Lake Jackson. Wakula Springs is a visible expression of that pressure. Where the aquifer pressure is low, or where surface conditions create sufficient weight to overcome the aquifer pressure, water can move downward, draining from the surface and into the limestone below. Downward movement of water is how lakes and streams can suddenly disappear into the ground. Lake Jackson sits directly above one of these potential drainage points. The lake basin was formed by karst processes. The depression that holds Lake Jackson is not a river valley, not a glacial scour, not a tectonic feature. It is a sinkhole basin, a broad shallow depression created by the gradual subsidence of the land surface as the underlying limestone dissolved over geological time. The basin contains direct connections to the Floridan Aquifer. These connections, Porterhole on the southwestern shore and Lime Sink on the northeastern shore, are vertical or near vertical conduits through the limestone that link the lake bottom to the aquifer system below. Under normal conditions, these conduits are sealed. Sediment, organic material, and clay accumulate over the openings during the years when the lake is full. The accumulated material forms a plug that prevents water from draining through the karst features. The plug is temporary. Over time, as sediment accumulates and the water column above it increases, the pressure differential between the lake surface and the aquifer below changes. When the aquifer pressure drops sufficiently, typically during drought conditions that reduce groundwater levels throughout the region, the weight of the lake water column can exceed the structural capacity of the sediment plug. The plug fails. The lake drains. 12 billion gallons of water flow into the aquifer, and 4,000 acres of surface water become 4,000 acres of exposed lake bottom, scattered with stranded fish, and littered with the boats, docks, and debris of the people who had been using the lake when the drainage began. The historical record is extensive. The drainage of Lake Jackson has been documented in increasingly precise detail for over a century. The 1907 event is the earliest drainage that was fully chronicled by contemporary observers. Local newspapers documented the phenomenon. Residents recorded their observations. The event entered the formal historical record of Leon County. The 1932 event followed approximately 25 years later. Again, the lake drained through the same features. Again, the water disappeared into the karst system. Again, the empty basin was documented by contemporary observers. The 1957 event continued the pattern. The lake had refilled during the intervening decades, reaching full pool and accumulating new sediment over the drainage points. Then the conditions shifted. The sediment plug failed, and the cycle repeated. The 1999 event was the first to be documented with modern monitoring technology. By September 1999, the Northwest Florida Water Management District had installed monitoring infrastructure around Lake Jackson. Water levels were tracked continuously. Aquifer pressure data was recorded from nearby wells. The drainage event was captured in real-time data that allowed hydrologists to reconstruct the sequence of events with unprecedented precision. The 1999 drainage took approximately 3 weeks to complete. The water level dropped steadily as the flow through Porter Hole increased. At peak discharge, millions of gallons per hour were flowing through the karst conduit into the aquifer below. The lake bottom emerged progressively. First, the shallowest areas near shore, then the deeper central basin until the entire lake bed was exposed. Fish died in enormous numbers. Boats that had been moored on the lake were left stranded on dry ground. Docks that had extended over the water now stood as elevated platforms over mud flats. The photographs from 1999 documented a landscape that seemed impossible. A major recreational lake transformed into a dry basin within weeks. The lake refilled over the following years as rainfall replenished the system, and aquifer pressure increased to the point where surface water could no longer drain through the karst features. The 2021 event repeated the cycle. 22 years after the 1999 drainage, the conditions aligned again. The sediment plug over Porter Hole failed. The lake drained. The phenomenon was documented with modern drone footage that captured, for the first time, aerial imagery of the entire drainage sequence. The footage showed the vortex forming over the drainage point as the water accelerated toward the opening. It showed the expanding ring of exposed lake bottom as the water level dropped. It showed the stranded boats, the dying fish, and the wildlife struggling to adapt to a landscape that had transformed beneath them. The 2021 footage went viral. For the first time, people outside the Tallahassee region became aware that this phenomenon existed, that a major Florida lake could simply disappear into the ground over a period of days. The December 2025 event came 4 years later. This was unusual. The historical pattern suggested a cycle of 15 to 25 years between major drainage events. The lake had drained in 2021. It should not have drained again until the late 2030s at the earliest. The 2025 event challenged the pattern. The lake had refilled after the 2021 drainage, reaching music near full pool by 2024. The sediment plug over Porter Hole had reformed. The system appeared stable. Then in December 2025, the plug failed again. The drainage was faster than any previously recorded. The 2025 event emptied the lake in less than 72 hours, far faster than the weeks-long drainage observed in 1999 or 2021. The acceleration suggested that the conduit system had been widened by the recent drainage events, that the karst features were eroding, and that the connection between the lake and the aquifer was becoming more direct. The footage documented a lake disappearing in real time. Drone operators captured the vortex over Porter Hole at full intensity, a swirling funnel of water descending into the limestone surrounded by an expanding perimeter of exposed mud. Time-lapse sequences showed the water level dropping visibly, hour by hour. The scale was difficult to comprehend. 12 billion gallons, 4,000 acres, 72 hours. The water went into the Floridan aquifer. It did not disappear. It did not cease to exist. It transferred from the surface basin to the underground system, where it would eventually re-emerge at springs, wells, and discharge points throughout the regional karst network. Wakula Springs, located approximately 15 miles to the south, showed increased discharge in the days following the Lake Jackson drainage. The connection between the lake and the spring system was not direct. The water had to travel through miles of limestone conduits, but the hydrological linkage was documented. The water that had been Lake Jackson was now part of the aquifer. It would eventually return to the surface, but the lake itself was gone. The broader context is what makes the event significant beyond Leon County. Lake Jackson is not unique. The Tallahassee region contains multiple prairie lakes, Lake Iomonia, Lake Lafayette, and Lake Miccosukee, that exhibit similar relationships with the underlying karst system. These lakes have their own drainage histories, their own cycles of filling and emptying, and their own connections to the Floridan aquifer. The phenomenon extends across north-central Florida. Anywhere the Floridan aquifer approaches the surface, anywhere the limestone is exposed or thinly covered, anywhere the karst system has developed direct connections between surface water and groundwater, the potential exists for sudden dramatic transfers of water from the surface to the subsurface. The 1981 Winter Park sinkhole demonstrated the most extreme version of this potential. On May 9, 1981, a sinkhole opened in Winter Park, Florida, approximately 250 miles southeast of Lake Jackson. Over a period of hours, the sinkhole expanded to approximately 350 ft wide and 75 ft deep. It swallowed a house, several cars, part of a swimming pool, and a portion of a municipal swimming complex. The Winter Park sinkhole was a collapse event, the sudden failure of the limestone roof over an underground void. Lake Jackson's drainage is a different mechanism, the opening of an existing conduit, rather than the collapse of a cavity roof. But both events demonstrate the same underlying reality. Florida's surface is not stable. The ground that appears solid is underlain by a dynamic karst system that can transfer water, sediment, and surface features into the subsurface with little or no warning. The development pressure is increasing. Leon County's population has grown substantially over the past several decades. Residential development has expanded into areas that were previously undeveloped. Some of that development has occurred around the margins of Lake Jackson and other prairie lakes. The people who built homes overlooking the lake understood in theory that the lake might drain. The reality is different from the theory. Watching 4,000 acres of waterfront property become 4,000 acres of exposed mud and stranded fish. Watching the water disappear into a hole in the limestone faster than it can be pumped, faster than it can be diverted, faster than any human intervention could prevent, is not the same as understanding abstractly that the phenomenon is possible. The 2025 event has prompted renewed questions about land use planning in karst terrain. Should development be permitted in areas with documented karst drainage? Should homeowners be required to acknowledge the risk before purchasing property near prairie lakes? Should insurance products be required to cover losses associated with predictable geological phenomena? These are policy questions and not geological questions. The geology is clear. Lake Jackson will drain again. The cycle has been documented for over a century. The mechanism is understood. The karst features are mapped. The connection to the Floridan aquifer is established. The only uncertainty is timing. The 2025 event, coming just 4 years after the 2021 drainage, suggests that the timing may be changing. The conduit system may be widening. The sediment plugs may be forming less effectively. The cycle may be accelerating. Or the 2025 event may have been anomalous, a statistical outlier that does not predict future behavior. The monitoring will continue. The Northwest Florida Water Management District MUSIC maintains observation infrastructure around Lake Jackson. Water levels are tracked continuously. Aquifer pressure is monitored through regional well networks. The data accumulates. Each drainage event adds to the data set. Each refill cycle adds to the understanding, and each generation of Leon County residents learns, as their predecessors learned, that the lake they have been swimming in, fishing in, and building their homes around is not permanent. It is borrowed. Lake Jackson rests above an underground world that has been changing for millions of years. Beneath the lake lies a vast network of limestone, a geological system slowly shaped and dissolved by water over unimaginable stretches of time. That process is still happening today, and it will continue long after the people living around the lake are gone. The lake's strange behavior was not unknown to the people who lived here long before modern Florida existed. The Appalachee people, indigenous inhabitants of the Tallahassee region, had lived alongside Lake Jackson for generations before European settlers arrived. Through oral traditions and cultural memory, they passed down knowledge of the lake's remarkable cycle. They had seen the water disappear, and they had seen it return. To the people who depended on and understood the landscape around them, the disappearing lake was not some unexplained mystery. It was simply part of the natural world they had observed for centuries. Later, European missionaries encountered the same phenomenon. During the 17th century, Spanish missionaries established Mission San Luis de Apalache in the region. Historical records from the colonial period contain observations about the unusual behavior of the lake. As Florida eventually became a U.S. territory in 1821, new generations of settlers began recording their own experiences. When major drainage events occurred, they became subjects of local conversations, community discussions, and family stories passed from one generation to the next. The technology used to document the phenomenon has changed. The phenomenon itself has not. The lake fills, the lake drains. Then, eventually, the lake returns. The reason is simple, but the geology behind it is extraordinary. The limestone beneath Lake Jackson has been shaped by water for millions of years. The Floridan aquifer beneath the region is constantly responding to changing conditions, including rainfall, drought, and fluctuations in groundwater levels. The underground karst system remains in place even when sediment temporarily blocks its openings. Then, when the conditions are right, those pathways can become active again. The December 2025 event provided a modern visual record of the same geological process that has occurred repeatedly throughout history. Billions of gallons of water disappeared from the surface basin. Thousands of acres of lakebed were exposed. Water that had once covered the landscape was suddenly replaced by mud, sediment, and exposed limestone. From above, the transformation looked almost unreal. Boats that had once floated across open water were left sitting on dry ground. Docks extended over empty stretches of mud. Fish became trapped in shrinking pools as the water level continued to fall. And near Porter Hole, the movement of water created a dramatic vortex, a visible sign that an enormous volume of fresh water was being pulled downward through the limestone beneath the lake. For anyone watching from the shoreline, it looked as if the lake had simply been swallowed by the earth. But the water had not vanished. It had moved. Below the exposed basin, the fresh water continued traveling through an underground network of cracks, channels, and conduits created by millions of years of geological activity. Eventually, some of that water would make its way through the Floridan aquifer and emerge again through springs and underground outlets across North Florida. The water was not destroyed. It was transferred from one part of the hydrological system to another. But for the people living around Lake Jackson, the difference was enormous. The lake itself was gone. The waterfront disappeared. Boating and fishing were disrupted. An entire ecosystem was temporarily transformed, and a landscape that had become part of the community's identity suddenly looked completely different. Yet the story does not end with an empty lake bed. The cycle is still moving forward. Eventually, rainfall will increase. Groundwater levels will change. Pressure within the aquifer will shift. The flow through the underground drainage system may slow, stop, or reverse. Little by little, water will begin returning to the basin. The lake will slowly rebuild itself. And once again, Lake Jackson will become a lake. But the question is not whether this cycle will happen again. It is when. Perhaps another major drainage event will occur in 15 years. Perhaps it will take 25. Or perhaps changing environmental conditions could shorten the interval. Whatever the timing, the underlying geological system remains. At some point, the conditions may align again. The natural barriers around the underground drainage features could fail, and once again, billions of gallons of water could begin disappearing beneath the surface. The geology does not follow human schedules. The karst system does not respond to property boundaries, roads, homes, or community expectations. Lake Jackson exists within a much larger underground system, one controlled by geological forces that began operating long before modern civilization ever arrived. For now, the lakebed remains exposed. But this is not necessarily the end of the story. It is simply another chapter in a cycle that has repeated for generations. Sediment will accumulate. Rain will fall. Groundwater levels will change. The underground system will continue evolving. And eventually the conditions will be right, once again. Lake Jackson has followed this pattern for far longer than humans have been documenting it, and it will likely continue long after today's observers are gone. The December 2025 event was not necessarily a geological disaster. It was a reminder of how powerful natural systems can be, and how little the surface tells us about what is happening underneath. The billions of gallons of fresh water that disappeared did not simply cease to exist. They became part of the Floridan aquifer, moving through ancient limestone pathways and underground reservoirs, potentially traveling toward springs and waterways across North Florida. The water is still there. The underground system is still moving. And one day, when the conditions are right, the water may return. The lake may fill again. The boats may float again. The shoreline may disappear beneath the water once more. But beneath it all, the limestone will continue its slow transformation, and Lake Jackson will continue its extraordinary cycle, vanishing, waiting, and eventually returning.